Now there's a few more that aren't really related to files and directories, and they aren't really related to comparison either. They're kind of special ones. Let's have a look at those. These are used in combination with the options that I've just shown you. Test exclamation mark expression. Now you read the exclamation mark as the word not, so you can think of this as returning not the expression. So if the expression is false, then test will give you a value of true, and vice versa. And the expression is one of the things that we saw earlier, like, is the file writable? Then you could say, well, I'll show you an example. Now we've just tested to see whether etc password is writable, and we found that it's not. So now let's test to see whether it is not writable. And we find that that is true. It is true, so etc password is not writable. We can also test to see whether two expressions are both true using the -a option. -a is short for and. You can read this as saying test to see if expression 1 is true and expression 2 is true. Now I'll give you a little demonstration of that as well. Here's a little script that ties everything together. We're using test in conjunction with an if statement, and we're actually using an elif clause as well and an else clause. So the first thing we do is we ask the user to enter a file name, read it in, and the very first thing we do is we test whether they actually did type it in. And if they didn't, then we give them an error message. Now if they did, then the next thing we test is whether the file that they specified exists, using test -f to see if it is a regular file and not a directory. And then we also test using the -a option for and to see if it is writable by us. And if so, we specify the appropriate message. So let's see this in action. The first thing we'll do is we'll run the program, and it says please enter a file name, and we won't. And it says you did not enter a file name. That is correct, I just pressed enter. Okay, we'll do it again, and this time please enter a file name, and I'll just enter some garbage. The file is not a writable file. That sounds pretty reasonable. Now how about if I run it again, and this time I say a file name of dot. Now dot is a directory. It's writable, but it's not an actual regular file. So we'll say it's not a writable file. It's actually a writable directory. Let's now try a file that is not a directory. It's a regular file, but it's read-only, and that is not a writable file. That's correct. And finally, we will try a real writable file, which, well, we'll use this one. Test file is the name of this actual program, and everything is fine because that is an actual writable file. Excellent. So that's the -a option in action. Similarly, there is a -o option. The -o is short for or, and you can read that as saying test will return true if expression 1 is true or expression 2 is true. In other words, if either one is true. Finally, we come to a very interesting fact about the test program. Test has an alias, and the alias is the open square bracket. Now that's a very odd name for a program, but that is an actual valid program name. So what I'm saying is, anytime you could have typed in the word test, you can now actually type in the open square bracket symbol instead. Now why would they do such a thing? Well, let's have a look. It means that our earlier example could have been written like this. Now, just test to see whether one variable is greater than the maximum. So we use the open square bracket instead of the word test. Now notice that there is a close square bracket there on the end of the line. And that's one of the curious features of the test program. If you use the alias of the open square bracket, then test will actually give you a syntax error if you forget to put in the closed square bracket. But if you just use the regular word test, then you don't need the closed square bracket. Let's just check that that actually works. I'm going to rewrite that little script that I just showed you. Let's have a look at that. Here's that script, and now I'll just go to this word test and put a bracket in like that, and I'll do the same thing here. Now, because I'm using the square bracket, I actually have to use the closed square bracket, and I'll do the same here as well. Okay, well actually, no. What I'll do is I'll omit the closing square bracket there, and I'll run this program and see if it works. So it says please enter a file name, and so I will enter one. Now notice there a missing close square bracket. So I'll run it again, and this time I'll put the square bracket in like that and execute that. Test 1, 2, 3. The file is not a writable file, that's fine, but notice that I did not get an error message, which means of course that the closing square bracket fixed the problem. Now why do you suppose that they've invented this particular curious alias for the test program? Well, if you've ever been a programmer before, then you might actually feel more comfortable with surrounding your test conditions with brackets. To your eyes, that might actually look like a more valid use of the if statement, which is, of course, exactly why it was done. So it would look more like an if statement from, say, the programming language C. Now, C uses round brackets instead of square brackets. The round brackets were already used for something in the shell, so they invented the use of the square bracket. So it's still the test program there, it's still running as the program called test, but it's pretending to be integrated into the shell and just a valid part of an if statement. So that's a little bit of cleverness there on behalf of the people that designed the test program. Now, because using the square brackets is actually much more intuitive when you get used to it than using the word test, or at least I find it to be, and most programmers that I know find it to be, this is actually the preferred use of the word test. Very few people actually write out the word test, T-E-S-T. Most people just use the square brackets notation because it looks better. It looks aesthetically more pleasing to the programmer's eye. So that's it. That's test. A very, very useful program. Probably 90% of the time that we use the if statement, we're also using the test program as well. Okay, let's move on. We now move on to an interesting language construct called the case statement. Cast your mind back to the if, elif, elif, elif statement, and I'll mention, and I'm sure you believe this is true, that when you use the if statement, quite often what you're actually doing is something similar to the following. You've got one variable and you're testing it against a series of values. Perhaps value 1, value 2, value 3, value 4, and you're doing a different piece of code for each one. In this example here, we're testing var1 equal to value 1, and if that happens to be true, then we run the code for case 1, and then the code for case 2, and so on. Now, there's a lot of coding going on here. We're writing out the if statement a lot of times. We're using test quite a lot. We're using the word then and elif quite a lot. And the equal sign, of course, in test is all being quite repeated quite often. Well, there is actually a nicer way of doing it. Nicer in the sense that it looks more aesthetically pleasing and more easy to understand on the screen. It still does essentially the same thing, but there's less work involved for the shell. And this is, of course, called the case statement, and it looks like this. We take our variable that we wish to compare to a bunch of values, and we put it in between the words case and in. And then for each of the different values that we want to compare it to, we put them on a line by themselves, and we put a round bracket after each option that we're comparing to. Then we put the code for that particular option. That might be several lines of code, that might be 100 lines of code, or it might be 0 lines of code. It doesn't really matter. But we put the code, whatever code that we want to run, if the variable happened to match that value, and then we put 2 semicolons next to each other. That is the case statement's way of saying this particular case or this particular option is now over and we're ready to look at the next option. You can actually put those 2 semicolons on the end of the previous line if you want to, which is actually nice to do if there is only one line for each case. One line of code, one option for each case. But if there are several lines, you tend to put the 2 semicolons on a line by themselves. Finally, when you've exhausted all the options, you put ESAC, which is case spelled backwards, just like phi, if spelled backwards. So let's see an example of the case statement in action. Here's a little script called case test, and as you can see, we ask for a rock group name to be entered. We read in the name, and then we compare that name with 3 different values. Those three values can have spaces in them, as you can see with the second example, dire straits. And for each case we determine another variable called no albums, or number of albums, and another variable called last album. And finally, after we've determined the number of albums and the name of the last album, we echo out that information to the screen. So it's a pretty simple script, but hopefully it demonstrates how to use the case statement. Let's test to see if it runs. We'll run that now, and please enter a rock group name. How about the Beatles, like that. The Beatles made 12 albums. The last one was called Let It Be. Okay, fair enough. And I'm sure you understand that it would work exactly the same for the other two choices. Now, what if we ran that again and we entered something that wasn't there, like Fatboy Slim, for example. Fatboy Slim just made albums. Didn't say how many albums. The last one was called, and it doesn't say that either. Okay, so clearly our script doesn't work very well if the user decides to enter a value that we didn't allow for. So with that in mind, let's move on and have a look at a little extension to the case statement that you can use to cater for such things. So this is somewhat similar to the else clause of the if statement, when you want to have a piece of code that is run if the value of the variable that you're matching doesn't match any of the above cases. In that circumstance, you simply create a case called asterisk or star. It looks like this. You can see we've got a little case called star there. It's exactly as we had before, except that will get run, the code in that case will get run if the value of var1 did not match any of the above cases. Let's go and have a look at that example working in our little sample script. Now in this case I've created a little case called star, and I simply, in that case, echo out the words unknown rock group and exit the program at that point, because really I don't want the echo on the last line of the screen to be done if there was an unknown rock group. So let's test that in action now. And so we'll enter the old Fatboy Slim again, and it's an unknown rock group. Okay, and that is exactly what we wanted to have happen. So I'll now just quickly show you a couple of other simple options that can be used with the case statement that just make it that little bit more user-friendly and useful. And the first one is that it's actually possible to specify that the same code be executed in several different cases, and you might do that like that. You use the vertical bar symbol or the pipe symbol. So here, where I've got code for cases 1 to 3, that actual code there will get executed if var1 happens to be equal to val1, val2 or val3. So I could adjust my little rock group sample script as follows. Instead of just allowing for Beatles, I could allow for the Beatles as well, in case someone decided to type it in like that. And let's test that. And we'll type in the Beatles, and the Beatles made 12 albums, blah blah blah. Excellent. Also, it's possible to use wildcard characters to match values to variables. As follows, we can say here D star, which means, of course, anything that starts with a D, just as it does with file names. So we can use the asterisk character, we can use the question mark character, we can even use the